Hello everyone, myself Dr. Mahmuda Khannam, Assistant Professor, Department of Chemistry, Pandit Deendayal Upadhyaya, Adarsha Mahavidyalaya, Dalgaon, Darrang, Assam, India. Here I am going to present our work on assessing essential parameters for soil fertility in remote agricultural areas of PDUAM Dalgaon, Darrang, Assam. Soil is defined as porous medium created at the land of surface through the various effects of weathering and influenced by geological, biological and hydrological processes. The quality of soil plays crucial role in agricultural activities. From chemistry point of view, soils are open, multi-component biochemical systems containing solid, liquids and gases. Soil consists of different layers or horizons. The O horizon is the uppermost layer of topsoil, mostly composed of organic matter like dried leaves, grasses, small rocks, surface organisms and fallen trees. The next one, that is A horizon or topsoil is a combination of organic matter and decomposed materials. It is soft and porous to hold sufficient water and air. The next one, the E horizon, undergoes leaching of minerals, clay and organic matter. B horizon is also known as subsoil, lies beneath topsoil and above the bedrock. It is comparatively harder. The next one, that is C horizon, lacks organic matter and composed of broken bedrock. Last one, that is A horizon, constitutes a compacted and cemented layer. Soil analysis is very much important for understanding physical conditions, fertility status and chemical properties which are suitable for growing plants. Soil fertility mainly depends on the presence of major nutrients such as nitrogen, phosphorus and potassium, as well as some other nutrients such as calcium, magnesium, sulfur, iron, zinc, copper, manganese, etc. in smaller quantities necessary for plants. A fertile soil also needs organic matter to improve soil structure, moisture retention, nutrient retention and an optimum pH of 6 to 7. For our study, we selected the remote agricultural areas of our college. The economic backbone of Darrang district stands on agriculture. The soil nature observed here is sandy to sandy loam in texture and clay in low-lying areas. Sandy loam soil has good drainage capacity, retaining its moisture. It is good for a wide range of plants and crops. In this study, we choose some areas of Dalgaon and Mandal constituency of Darrang district, Assam, India. The samples collected from 8 villages which are Podupuri, Jogipara, Nisamabari, Samtila, Simaluguri, Duliapara, Doipam and Dhekeri. 3 different types of soil samples were selected for our study. Number 1, that is inorganic soil sample, where only inorganic chemicals such as fertilizers or pesticides are used. Next one is organic soil sample, where no inorganic chemicals were used, only organic substances were used for cultivation. And third one is uncultivated soil sample, where the land is not used for cultivation for a long period of time. Samples were collected from different layers ranging from 0 to 2, 2 to 4, 4 to 6 and 6 to 8 inches from soil surface. So all total 164 samples are collected for our study from 41 different areas. For pH measurement, our pre-treated soil samples, which are almost about 10 gram, is dissolved in 50 ml of distilled water, followed by frequent stirring. After keeping the solution for near about 2 hours, soil water suspensions were poured into another beaker for pH measurement. pH measurement shows that most of the studied area exhibited pH in the range of 6 to 7, that is almost 67%. 21% is more than pH 7 and 12% is less than 6. So we can say that soil in our studied area tends to be slightly acidic to moderately alkaline. The electrical conductivity measurement values can vary with the concentration of salts in the soil. The conductivity values determine the concentration of dissolved ions present in soil. A soil is considered as saline if the conductivity value equals or exceeds 4 decicement per meter at 25 degrees Celsius. A soil electrical conductivity value in the range of 0 to 1.5 decicement per meter is very good for plant growth. The investigation shows soils from studied area are almost non-saline. So here we can see that 76% is showing electrical conductivity value less than 0.250 millisiemen per centimeter, then near about 21% in the range of 0.250 millisiemen per centimeter to 0.750 millisiemen per centimeter, and 3% is showing electrical conductivity value greater than 0.750 millisiemen per centimeter. To determine the presence of various necessary ions present in the soil sample, at first soil extract was prepared, that is prepared by adding 10 gram of soil in 50 ml of distilled water, followed by continuous stirring for near about 30 minutes. The suspension is allowed to stand for another 2 hours, followed by filtration of 2 to 3 times to get the clear solution. The volume of the filtrate is reduced to 20 ml by heating and used for analysis of different ions. The ions we choose were chloride, sulfate, nitrate, phosphate, calcium, magnesium and ammonium ion. Few drops of silver nitrate was dissolved to acidified soil extract by adding dilute nitric acid to test the presence of chloride ions. Cardi white precipitate insoluble in dilute nitric acid but soluble in ammonium hydroxide solution indicates the presence of chloride ions. Similarly, few drops of barium chloride solution were added to soil extract to detect the presence of sulfate ions. Heavy white precipitate implied the presence of sulfate ions. To detect the presence of nitrate ions, equal volumes of freshly prepared ferrous sulfate solution was added to soil extract. It is followed by cooling under tap water and dropwise addition of concentrated sulfuric acid. Formation of a brown ring indicates the presence of nitrate ions. The presence of phosphate ions confirmed by changing soil extract color to yellow on addition of equal amounts of concentrated sulfuric acid and ammonium molybdate, which is then followed by boiling. Addition of Nessler's reagent under alkaline condition confirms the presence of ammonium ions by formation of brown precipitate. Soluble calcium and magnesium ions present in the soil extract were determined by complexometric titration using EDTA in the presence of suitable indicators, pattern and readers indicator and aerochrome plate T. From our analysis, we observed that with the exception of 1 or 2 samples, all soil samples showed the presence of chloride, sulfate and phosphate ions. The absence of nitrate was observed in samples from Simaluguri, Podupuri, Doipam, Siamtila, Siamabari and Duliapara. The analysis of cations like calcium, magnesium and ammonium showed their presence in all of the samples. From our study, we can conclude that the pH investigations revealed a prevalent range of 6 to 7. The electrical conductivity was found to be less than 4 decicement per meter in the studied area. The analysis of soluble ions indicated the predominance of chloride, sulfate and phosphate ions in majority of samples, with the notable absence of nitrate in few samples. Calcium, magnesium and ammonium were present in all the samples. From the qualitative examination, we observe the presence of all the essential elements necessary for plant growth in the investigated area. In near future, a more in-depth quantitative study is essential to determine the soil ion composition and also to understand the soils necessary soil supplementation in that region. Finally, I want to thank Dr. Kalpana Upadhyaya and Dr. Moon Mandal for their contribution in this work, and also the students from Department of Chemistry, PDUAM Dalgaon, for their assistance in the research work. And finally, the college Pandit Deendayal Upadhyaya Adarsha Mahavidyalaya Dalgaon Darrang for providing us all the necessary facility. Thank you.